Hello everyone, welcome to Ganit Online. Here, the main topic in this video to be discussed is definition of the limit. So we are going to understand what the limit is and where it will be applied, or we can say that when the limit exists, what is the normal definition of a limit. So the mathematical definition here I've written. So you should understand it carefully. I'll be going line by line. So he's saying that is let E is a subset of R and F from E to R. So F from E to R denotes that E is the domain and R is the range. And he's saying that A belongs to R. So a small letter A belongs to R such that A minus R and A plus R and flower bracket A. So these are the intersection of E is a non-empty for every R greater than 0. So it is here he is giving us the functional definition. So what is range and what is domain, and if that a small number or element belongs to R. So what happens is giving in this video, and again he's explaining that if there exists a real number L satisfying the condition below, then L is said to be the limit of f at A. Here he is telling that if there exists an L, there exists a real number L satisfying the condition below, then L is said to be the limit of f. So limit is nothing, it's very easy. Here limit extends to A f of x. So directly what we have to do is that you have to apply this x tending to A, x is equals to A in the functional value. So if you apply it, so then you'll be getting some result. So that result is known as L. So we can say that as x approaches to A, f of x approaches to L. So we can say that the limiting point or the limiting value for x tends to A is f of A. F of A, or like we can say that f of x tending to L. So is nothing but it happens only when x tends to A. So this is the normal and simple definition of a limit. Nothing, limit is nothing, just it is a functional value of corresponding x. So we'll be understanding the limit in detail. You may ask, sometimes the function is not defined and sometimes we cannot apply the value at any scenarios, like if the denominator gets, like if in a function f is equals to 1 by x minus 2, there if you apply 2 then the function doesn't make sense. So you can say that in that sense what happens, the limit exists or limit doesn't exist, or you can say, so in those cases we have some special exceptions and we have some special theorems to solve those type of problems. So now, as of now, you remember that limit is nothing but it is just a functional value, a functional value of the x. So that it is limit, we cannot say that the limiting value is the exact answer. So exact answer, so it is tending value. This f of x tends to L, but f of x is not equals to L. It is tending to L, it is approaching to L. As x is approaching to A, that thing you have to keep in your mind. Limiting value is always the nearest value, tending value, not the absolute value. Okay, so you may get these type of questions in your competitive exams. So limiting value, how to find the limiting value and all those things, generally you will be tested where the limit exists. So here, and this will be the second part of the definition. Given epsilon greater than 0, there exists a delta greater than 0 such that f of x minus 1 is less than epsilon whenever x belongs to E and x minus a lies between 0 and delta. In this case, we say that limit of a function f of x tends to a exists, this exists, so this value exists and it is L, and we write it as this one. So nothing, here he has given the same description in other way. So you need not by heart, or you need not understand all the mathematical definition. You just simply remember it as limit extends to a, f of x is equals to L is nothing but the functional value of f of x at x approaching a. If x approaches to a, f of x approaches to L. So this is the simple definition of a limit. That's it. If in case if the such an L doesn't exist, we say that f of x does not exist. So what he's telling, if the value, like if x plus 1 by x minus 2, let's say that function is, for example, x plus 1 by x minus 2 and limit x tends to 2. So if in this case, if you just directly substitute in x 2 plus 1 by 2 minus 2. So x is tending to 2, and this is some 3 by 0. 3 by 0 is, it's meaningful, it's infinite. Okay. So this f of x is tending to infinite. So we can say that at 2, at x tending to 2, the limit is not defined. It doesn't exist. So that we can say. So here clearly you have understood when limit exists and when limit doesn't exist, and what is the basic definition of a limit in a mathematical way, in highly mathematical way, and in normal sense. So I'll be giving a beautiful example. What is a limit? So it's more or less related to geometry. So this is a circle. So this is a circle. This is a circle. Okay. So now this is a chord. This is a chord. So what is the limiting value of this chord for this circle? So can anybody say? Think. So if it is something, you just drop down in the comment now. That before, you shouldn't watch the video completely and you should drop. So soon at this point you drop the comment. Think for some time. So we can say that the limiting value is, at some point it grazes. So this line is known as tangent. This is known as tangent. Tangent of tangent. That's all. Tangent this circle. So this is a chord. So what is the limiting point? So what is the limit in the English version or English meaning? That is the maximum point where everything is fine and where everything is safe. If it is beyond that point, then it has crossed its limits. It has crossed its dimension. So that we can say that that is the limit of the corresponding scenario. Here in this scenario, the chord limit, the chord limit of chord is a tangent. So that we can say. So here limits can be understood in that way. So now I will just explain when the limit exists. When the limit exists. Very important. So many people, not only class 11th or class 12th, people who have completed their graduation or people in masters don't know what is the when a limit exists exactly. So you try to understand this one. If you understand the limits concepts very clearly, you can easily understand the differentiation, because differentiation is derived from the limits. It is derived from the limits. So that's it. So now we'll understand. So limit. So take this as a line, and this is a point A, and this is a point A minus delta, and this is a point A plus delta. So this is very small, negligibly small. So this is in the order of 0.0001. Okay, this is also 0.0001. This length angle. Okay, So this is x value. This is x. X is a minus delta, a and a plus delta. I have taken 3 points. Okay. And now limiting value f of x. So I say that any function f of x is there. Okay. So limit x tends to, here this we can write it as, this complete thing we can write it as a minus, this complete thing we can write it as a plus. Limit a tends to a minus f of x is left hand limit. Left hand limit. Limit x tends to a plus f of x. This is right hand limit. So what is the left hand limit and what is right hand limit? Limit if the value, the x value approaches to a from left side. From left side, it is tending to a, mind you, it is not a, it is approaching a, from left hand side, then that limiting value is known as the left hand limit. If the corresponding value x is approaching a right hand side, from right hand side, so it is a plus. This a plus is approaching a in this right hand, so a plus. So this is tending from LHS and this is tending from RHS. So if these two values, if you say something meaningful, you should think that this value and this value should be equal. In that case, we can say that the limiting value exists. So if one is approaching that corresponding value from one side, if he is getting other answer, and if he is approaching from the left side and if he is getting the other answer, so if though both are not same, both are not correct, then we can, so in that case limit doesn't exist. It's natural, no? So if it is from left hand side and right hand side, so the value will be a, but it is not some b or c, it's not like that. So in that case the limit exists. So we can say that limit exists only if left hand limit is equals to right hand limit. So limit of x tends to a minus f of x is equals to limit of x tends to a plus f of x. This, if this is true, then the limit exists. So that's it. That's all the value of the complete concept of the limits. So what we have learned in this video. So the first thing is that we have learned what is the definition of limit. We have learned what is definition of limit. What it is? It's nothing but the functional value of the x, or if you can say that if x is approaching some number, then f of x should approaches to other number. So if x is approaching to one number, say if x is approaching to a, then f of x should approach to some meaningful value L. So in that case we can say that the limiting point of this corresponding value is this one. That is the basic definition of a limit. You need not remember the mathematical definition. If you are very interested, then you can always do it. But for normal understanding, you can understand in this way. Limiting value is the functional value. If x is approaching to some number, then f of x is also approaching to the other number, and that should be meaningful. That is the definition of the limit. Limit exists only if the left hand limit and right hand limit of that value is same. So that is the definition of the limit. So limiting, we have learned what is the definition of limit, and we have learned condition for limit to be existed. So that's it in this video. We have learned. So yeah, if you are interested or if you want to learn more, so please subscribe to our channel Ganit Online. Yeah, thank you.